Hi guys, so we are finally on our last learning target for Unit 2, and this is on one variable absolute values, okay? So by the end of our lessons for Unit 2C, you should be able to solve absolute value equations and inequalities with one variable. You should be able to interpret solutions both algebraically and graphically on the number line. And you should be able to construct absolute value equations and inequalities given constraints and in the context of real-world applications. Okay, so we're going to start off with our toolbox. Okay, and this is where you go when you need quick information usually. Okay, so let's start with absolute value. This whole learning target's about absolute value. So what is it? Okay, absolute value is the distance from 0 on a number line. And because absolute value is distance, absolute value cannot be negative because we cannot have negative distance. Okay? It wouldn't make sense to say, oh, I went negative 3 feet. That does not make sense. Okay? So that's why absolute value is always positive because we're talking about distance. Okay? So absolute value equations look like this, okay? Ax plus b. Okay, so the absolute Ax plus b equals c. Okay, A is a coefficient and b and c are our constants. Okay, in order to solve an absolute value equation, we split it up. Okay, we have one equation where it equals c. And then we split it up to a second equation where it ends up equaling negative c. Okay, and when we split it up, okay, it ends up the absolute value symbols go away. Okay. So that's our absolute value equations. It's an equation because of the equal sign. Okay, and then we have absolute value inequalities. Okay, so we have two types of absolute value inequalities. So one is where our absolute value of Ax plus b is less than c. Okay. I'm going to split this here. And we have an absolute value of Ax plus b when it is greater than c. Okay, so the difference, one is a less than symbol where our absolute value is less than something. The other one is where our absolute value is greater than something. So when we have our absolute value less than c, this is our and inequality that we talked about. Okay. And so to help you remember this, okay, since this is less than, right, so less than sounds like and. Okay. And you hold a barbell in your hand. And when we have an and inequality, we write it like this. We have negative c less than what we had in our absolute value, Ax plus b, less than positive c, right? So here you can see that and inequality. And when we end up graphing it, it ends up looking like this. Okay, so to help you remember, when it's a less than, that's an and inequality. Think less than sounds like and. You hold a barbell in your hand. This, the graph, looks like a barbell, okay, or a dumbbell. Right, so if you think about it, here's my little person, right? He's holding a little, like, dumbbell. He's working out. Okay, so that kind of helps me remember it, right? So my absolute value when it's less than and inequality. Less than sounds like and. You hold a barbell in your hand. It looks like a barbell when I graph it. Okay? So when it's greater than c, our absolute value is greater than c, this is an or inequality. And how I remember it is greater, sounds like or, like oars on a boat. Okay. And so when we have this, we have ax plus b less than negative c, or we have ax plus b greater than c. Okay. And when we graph it, it ends up like this. Okay. So again, how I remember this, when our absolute value is greater than c, that's an or inequality. Greater sounds like oars of a boat, right? So drawing a little picture to help us. Okay, like oars of a boat, right? They're going in opposite directions. Okay. So you hear me say it again and again when we get to absolute value inequalities. Okay. But today, we are going to talk about absolute value equations first. Okay? So if you consider the equation, the absolute value of x equals 3, okay, one way we can write it, okay, is the absolute value of x minus 0. Okay? This doesn't do anything, right, but it'll help us understand our absolute value. Okay? So I can rewrite this as the absolute value of x minus 0 equals 3. Okay? And what this means is this x minus, right? The reason why I put an x minus, okay, is because this means distance from, right? So if you think about it, if I ask you what is the distance from 6 and 3, right? What's the distance from 3 to 6? You would subtract, right, to find that distance, right? Or if I ask you what is the distance from 8 to 2? Or 2 to 8, right? You would subtract that and you would get 6, right? That 8 is 6 away from 2. So that's why it's minus. So the x minus means distance from. Okay. So this means the distance from 0 is 3. So using that interpretation, let's sketch it on the number line, right? So the distance from 0. So here's 0. If you count what is 3 away, right? And so this is 0. We count, this is 1, 2, 3 away. Right? But you can also go this other way. So a distance of 1, 2, 3 away. Right? So using the sketch, we can see that both 3 and negative 3 are a distance of 3 away from 0. Okay. So what about the next one here? So consider the equation x minus 5 equals 3. Okay, so again, this x minus means the distance from okay. So in this case, we're talking about the distance from 5 equals 3. So the distance from 5 is 3. Okay. So let's see where 5 is, right? So 5 is here on our number line. So let's see what is 3 away. Okay, so if I go to the right, 1, 2, 3, this here is 8. Right? If I go here, 1, 2, 3, this here is 2. Right? So based on this, I know that both when x is 2 and 8, that gives me a distance of 3 away from 5. Okay. Right, so let's look at another one. Okay. So here we have x plus 5 equals 3, right? And we know another way to write this is I can write it as x minus negative 5. Right? Because normally we go the other way, right? When we minus a negative, that means plus. Okay, so let's interpret what this means. Okay, so again, this x minus means distance from. So this x minus means distance from, when we're talking about absolute values. Okay, the distance from what? The distance from -5 is how much? According to this, is 3. Okay, so we're finding what has a distance of 3 away from 5. So this can be rewritten as this, and what this means is that the distance from -5 is 3. Okay, so let's look at where -5 is on my number line. Okay, that is right here. So let's see what is 3 away. Okay, so if I go to the right, 1, 2, 3. This here is -2. Okay, and if I go on the left side from -5, 1, 2, 3. This here is -8. Right? So what two numbers have a distance of 3 away from -5? That is -2 and -8. Okay. So if we use the same reasoning to solve all of our absolute value equations, notice that all we have to do is create two cases to represent distance, one for the right side of that number and the other one for the distance on the left. Right? So let's solve using that idea. Okay, so what we do is that when we have an absolute value, okay, what we do is we split it, one representing our left distance and one representing our right distance. Okay. And note that when we split it up for both sides, our absolute value symbols are gone. Okay, so let's solve. Okay, so here I have x minus 4 minus 10 equals -2. Okay, we're going to check our solutions because sometimes when we talk about absolute value equations, we have extra solutions. Okay, they're called extraneous solutions. Okay, and we are going to plot the solution set on the number line and interpret it with a graph. Okay. So I'm going to write my equation. X, absolute value of x minus 4 minus 10 equals -2. Okay. So one thing important is before you split it up, the absolute value has to be by itself. Okay, so here you can see that my absolute value afterwards has a -10. So the first thing I have to do is get rid of this -10, and we do that with inverse operations. So to get rid of -10, I add 10. Right? Then it leaves me with the absolute value of x minus 4. -10 and plus 10 simplify to 0, right? So plus 0. That's why it's no longer there, because plus 0 doesn't do anything to it. And then -2 plus 10 is 8. Okay. Once the absolute value is by itself, we split them into two equations. Okay. One, we take what's in the absolute value, so x minus 4, and we make it equal to negative this. And then we take what's in our absolute value equals positive that. Okay. Then it's solving equations, which we're good at, right? So all I have to do is add 4 here. Okay. To get rid of my minus 4. So this simplifies to x plus 0, which is just x. And then -8 plus 4 is -4. Okay. So this is one of my answers. Okay. Then I solve the other one. So here again, to isolate x, I need to get rid of my minus 4 by adding 4. Okay. This simplifies to x plus 0, so that's just x. And 8 plus 4 is 12. Okay. So like I said, sometimes we have extra solutions. Okay. So what we're going to do is we're going to plug it back in to see if it's true. Okay. So all I'm doing is plugging in this -4 back into x. Okay, so that's why you see that here. Okay, and then I'm going to do the same thing. I'm going to plug in 12 for x to see if it's true. Okay. Please make sure you're able to read your own handwriting. Okay, you should know the difference between whether it's an absolute value symbol or if it's a 1. Okay, so negative 4 minus 4, this is negative 8. Okay, so the absolute value of negative 8 minus 10 equals negative 2. Okay. Absolute value turns what we have inside positive, so the absolute value of negative 8 is 8. Okay. Right, so no, I never touched that right side. Okay, and then 8 minus 10 is negative 2. Negative 2 equals negative 2. Yes, it checks out. That is true. So x equals negative 4 is a solution. Okay, so let's check to see if 12 is. Okay, so 12 minus 4 is 8. So the absolute value of 8 minus 10 equals negative 2. Okay. Absolute value of 8 is just 8. Okay. Again, note how I'm not touching anything on this side. I don't need to simplify or move anything there. Okay. Then 8 minus 10 is negative 2. Negative 2 equals negative 2. Yes, it does. So x equals 12 is a solution. Okay. So let's write some notes to ourselves about solving. Okay. So first, important to remember, you must isolate, right, the absolute value before solving. Okay, so before you can let's write before separating it. Before separating into two equations. Right? So note here, right, that we had to get rid of this minus 10 in order for my absolute value to be by itself. Okay, so before you separate it into two equations, your absolute value has to be on a side by itself. Okay. The next thing is you need to check your solutions, okay, after you're done solving. So here, right, we checked our solutions. And the reason why is because absolute values can sometimes have more than one solution. Okay. Third thing to remember is that once the absolute value is on a side by itself, separate it into two equations. Right? So we saw that, right? Once my absolute value here was by itself, we separated it into two equations. Since our absolute value equals 8, I did it where one equaled negative 8, the other one equals positive 8. Okay? And when you do separate it into two, right? So when you separate, okay, note that the absolute value signs go away. Right? So once I split it into two, you don't see the absolute value signs anymore. Okay? So that's important to remember as we do example 5. Okay? So here we have the absolute value equation 2 times the absolute value of 5x minus 1 plus 6 equals 28. Okay, we're going to check our solutions and plot our solution set. Okay. Oh, I forgot to graph it. Sorry, so for this one, right, we have 4, or negative 4, as one of our solutions, and 12. Right. And you can see that that's because, right, from the distance from 4 is 8. Right, so you can see that, right? 5, 6, 7, 8, 9, 10, 11, 12. 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4. Right, so this meant the distance from 4 is 8. So 4, 8 away was negative 4 and 12. Okay, so sorry, back to this. So I'm going to copy down my equation. 2 times the absolute value of 5x minus 1 plus 6 equals 28. So again, right, keep in mind that you want, you need to remember what is an absolute value sign and what is a 1. Okay, so keep that in mind. Okay, so first, right, we must isolate the absolute value before separating into two equations, right? So we're going to do reverse order of operations, right? So the absolute value is a type of grouping. Okay, this is a multiplication, this is addition, right? So I'm going to take care of my addition first by subtracting 6. Okay. The plus 6 minus 6 simplifies to 0. It's plus 0, that's why we are not writing it anymore. 28 minus 6 is 22. Okay. Then I still need to isolate the absolute value before solving, right? So this is 2 times the absolute value. Okay, so to get rid of that 2, I'm going to divide by 2. Okay, this simplifies. 2 divided by 2 is 1, so now it's 1 times the absolute value of 5x minus 1. Okay, equals 22 divided by 2 is 11. Okay. Now that my absolute value is by itself, I can separate it into two equations. Okay, so I take what's inside the absolute value, so 5x minus 1, it's going to equal negative 11. Okay. And then the other one, I take what's in the absolute value, equals positive 11. Okay. Then I solve. Okay, so this, after that, is just like solving an equation. Okay, so I'm going to add 1, okay, to get rid of my minus 1. Negative 11 plus 1 is negative 10. Okay. Then I'm going to divide by 5, and I have x equals negative 2. Okay, I'm going to check that solution later. Okay. Then I'm going to work on the next one. To get rid of my minus 1, I'm going to add 1 to isolate x. Okay. Negative 1 plus 1 is 0, so 5x plus 0 is just 5x. 11 plus 1 is 12. Okay. Then I'm going to divide by 5. Okay. So x equals 12 fifths or 2 and 2 fifths. Okay. But when I plug it in, I'm going to plug in 12 fifths to check. Okay, so now we need to check our solutions because for absolute value, sometimes we have extra solutions. So I'm going to plug in negative 2. For x. So I'm actually going to check using red. So 2 times the absolute 5. Instead of x, I'm going to write my solution of negative 2 minus 1 plus 6 equals 28. Okay, then I solve. Okay, so 5 times negative 2 is negative 10. Negative 10 minus 1 is negative 11. Okay. Note that whatever I'm not touching, I'm leaving inside. Okay. Absolute value of negative 11 is positive 11. So this means 2 times 11. Right, because absolute values turn it positive, so that's why the negative 11 becomes positive 11. 2 times 11 is 22. 22 plus 6 is 28. Okay. Does 28 equal 28? Yes, it does. So that means x equals negative 2 is one of my solutions. Okay. So it is a solution. Okay, so now I'm going to test 12 fifths. Okay, so I'm going to plug that in for x. Okay. I will use red. Okay. Okay. So I'm going to do my absolute value first, right? So this 5 and this 5 cancel out, right? They simplify. This is times 5, divide by 5, so that leaves me with just 12. 12 minus 1 is 11. Okay. Absolute value of 11 is 11. Okay. 2 times 11 is 22. 22 plus 6 is 28. Does 28 equal 28? Yes, it does. So that tells me that 12/5 or 2 2/5 is a solution. Okay, there you go. Okay, just like we have special cases with equations and inequalities, there are also two special cases that we need to consider when we're solving an equation. Okay, so let's solve. Okay, so as always, before you split or separate your absolute value equation, you need your absolute value by itself. Okay, so here you see that the absolute value is followed by a plus 2. So to get rid of the plus 2, you need to subtract 2. Then I'm left with the absolute value of 3n plus 4 here. The 2 minus 2 is 0. That's why you don't see it. And the 2 minus 2 here is also 0. Okay? So this tells me the absolute value of 3n plus 4 equals 0. Okay, whenever our absolute value equals 0, because there isn't a positive and negative 0, all we have to do is write one equation. Okay? Here, now I get to solve. Right? So for whenever your absolute value equals 0, there is no need to split into 2 because there is no positive or negative 0. Okay? Then we can just solve. Okay, so I'm going to subtract 4, okay, so I can get n by itself. So since it was a plus 4, I do the inverse operation, which is minus 4. Okay? And then here 0 minus 4 is negative 4. Okay? Then, since this is 3 times n, to get rid of that times 3, I divide by 3. Okay. So n equals negative 4/3 or negative 1 1/3. Okay. So as always with absolute value equations and inequalities, we are going to test our solution. Okay. So I'm going to take this negative 4/3 and plug it back in for n. So the absolute value of 3 times negative 4/3 plus 4 plus 2 equals 2. Okay, so let's solve. So this is multiplying, right? So this times 3 and divide by 3 simplify to 1. Okay, so it ends up being just 1 times negative 4, so that's negative 4. Okay, and then plus 4 plus 2 equals 2. Okay. Then negative 4 plus 4 is 0. So the absolute value of 0 plus 2 equals 2. Absolute value of 0 is 0. Okay. 0 plus 2 equals 2. So 0 plus 2 is 2. Does that equal 2? Yes, it does. So negative 4/3 or negative 1 1/3 is a solution. Okay. So now let's do this next one. Okay, again, before you split your absolute value equation to solve, it needs to be by itself. Okay, so here you can see that the absolute value is not on a side by itself. It's being multiplied by 3. So here, to get rid of it, I'm going to do the opposite. I'm going to divide by 3. Okay. So this simplifies to 1. So 1 times the absolute value of x minus 8 is just the absolute value of x minus 8. Negative 6 divided by 3 is negative 2. Okay. So when we're talking about absolute value here, now that it's by itself, I'm saying that the absolute value is negative 2. Since absolute value is distance, distance cannot be negative. So whenever your absolute value, when it's by itself, equals a negative number, there is no solution. Okay. And the reason why is because absolute value cannot be negative. And so my answer is no solution. And the reason is because my absolute value here equals a negative number. Okay. So that's it for today on solving absolute value equations. We are going to practice, okay, next time. So have a great rest of the day. Bye, guys.